What's happening, dogs? Mr. Allen here with some evaluation of trig functions using our half-angle formulas. And for this one, we've got tangent of theta is equal to -5/12. I'm feeling a Pythagorean triple here. Theta is restricted into the, it looks like, second quadrant between pi over 2 and pi. And we got to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. All right, first step for something like this is let's draw our triangle in standard position here. So we're going to go with a lovely little XY coordinate plane here, and I'll draw it in the second quadrant. Now it's -5/12. This is my opposite, and this is my adjacent, right? Do we really think that the opposite's going to be negative? No. This is a +5, and this is a -12. With tangent, you got to be careful with that because it's usually written with the negative either in the numerator or out in front, which can be misleading, okay? So there we go. We got -12 here for my adjacent side. 5 is my opposite. 13, Pythag for the win here. 5, 12, 13 triangle to fill this guy out. All right, so that's where I've got theta, all right? Now, a couple things here is we know that theta is between pi over 2 and pi. So where's theta over 2 going to be? Well, if I divide this by 2, I'd have to divide this by 2. I'd have to divide this by 2. Which means I'm going to be between pi over 4 for theta over 2 and pi over 2. Well, where's theta? Where's pi over 4 and pi over 2? That is looking like it's between from either here or straight up, right? That's pi over 2 right there. So we're somewhere in here that this theta over 2 is going to be located. So what we're really getting at here is it's going to be in the first quadrant, okay? That's going to be in the first quadrant. So all my answers will be positive, okay? My answers are going to be positive for this one. So that's how we did that, all right? Because we got our plus or minus and our plus or minus for our cosine and our sine and our cosine. I know theta over 2 is going to be in the first quadrant, so all of my answers should be positive here. I don't have to worry about the plus or minus anymore. I've already made that distinction. All right, let's go for it, man. I'm going to start over here and probably work my way backwards over this way. So let's start with sine. I will go with a neon yellow. It looks very similar to the green here, but it is a little bit different, I swear. All right, so sine of theta over 2. Well, that's going to be this right here, which is going to use cosine. So I'm going to have, so sine, let's make it a little, yeah, that looks almost exactly the same. Sine of theta over 2, so theta over 2 equals plus or minus, wait, we already know it's positive, so I don't even need that. Square root of, I had a college professor that would go, square root of, he sounded like Count Dracula, it was awesome. All right, 1 minus, what's cosine of theta? Cosine of theta is -12/13. So -12/13 all over 2. And now we're just working with fractions, man, which I know fractions are rather scary. Very scary. You'll be all right. It's going to be fine. Don't worry. It'll be great. Let's see here. I'm going to multiply by 13 and 13 here. So multiplying by 13 over 13, that's like multiplying by 1, and that doesn't change anything. That's mathematically equivalent. It's totally legal to do. Why did I choose 13? This denominator right here is 13. So these guys are going to poof, poof, but it'll still be multiplied to that 1. So let's show that right now. 13 times 1, so this is still all in a big square root. 13 times 1 is 13. This is positive, so plus 12 now, because the 13 and that 13 cancel, right? It distributed into both of those. All over 26. So now we have the square root of 25, right? So that's kind of nice. 25 over 26. So let's simplify this, and I'm going to work maybe this way now. Actually, we're going to go down one more time. That's going to be 5 over the square root of 26. Now, unfortunately, in math land, we say, can't leave a radical in the denominator. You have to rationalize it. Why? I don't know. Some old dude decided a long time ago it was easier to approximate things with long division if the radical was in the numerator rather than the denominator. Anyways, now we follow this whole procedure blindly. I think it's a waste of time because that's totally fine with me. But in the mathematical community, no, we can't have that. So here's what we got to do. We got to rationalize. We're going to multiply by root 26 over root 26 to get this thing to be 5 square root 26 over 26, because that looks a lot better than that. No, I disagree, but that's what we have to do to follow common procedures or all agreed upon procedures. I say, let's get rid of rationalizing the denominator. It's a waste of time. No longer need to do that, right? Band with me. I'm going to start a GoFundMe or whatever it is, petitions or whatever. College Board, you got to get on board here. Let's make this the okay answer. That looks worse anyways. There we go. Okay, I'm done. Rant over. Rant over. Until I probably have to rationalize again in a future problem here in this whole mess. All right, but sine of theta over 2 is done. All right. Let's continue. Got kind of hot there. All right. I'm going to come back actually up here now, and hopefully we have enough room for all three of these here in this lovely little problem. All right. So now we're going to do cosine of theta over 2. So cosine theta over 2. Now, we already know it's positive, right? We've decided that. It's in the first quadrant, as you see, somewhere in this little vicinity here between pi over 4 and pi over 2. So we got the square root. It's going to basically look like the same thing, almost 1 plus, what's the cosine of theta? It's negative 12 over 13 over 2. And most of this is going to work out, again, very, very similar to the last one. So I'm going to bring myself over here so I have enough room to work. We got square root of, and I'll multiply by, 13 here. Oops, that's a 12. 13 and 13. So that's going to give me, it's an ugly 3. 13 times 1 is 13. Then we have the 13 and the 13 cancel, so minus 12 over 26 equals, that's 1. So we have the square root of 1 over 26, which is equal to 1 over square root of 26. Oh my goodness. I can't leave that. We have to rationalize by root 26 over root 26. Oops, that's it. Oh my God. Oh, that's terrible. Anywho, this is the whole process of rationalizing is terrible. I should stop complaining. It's a complaining pants city over here. But hey, man, I've never liked rationalizing the denominator. I feel like it's a waste of time. Now, does this look better than that? I'm back on the rant, man. I don't know, but that's the answer right there. Square root of 26 over 26. Final answer. All right. Last one here. Got tangent. I think we got enough room to do this thing all the way along the bottom right here. Hopefully. We'll see. Oops, I made a mark. All right. So tangent is actually a pretty nice one because there's no square root, right? Which is lovely. So we got tangent of theta over 2 equals 1 minus, well, cosine of theta, we know is negative 12 over 13 all over sine of theta, which is 5 over 13. So what I'm going to do here is I'm going to multiply by the reciprocal. Okay, so we're going to multiply by the reciprocal of that denominator, which is then 13 over 5. So that's going to give me this. Yes, this is official mathematical notation for multiply by the reciprocal. No, it's not. That's street math right there. But I think it works out pretty well. It tells me what to do. Hopefully it tells you what to do. All right, so we got 13 over 5 times 1, which is 13 over 5. And then it's negative, negative, which makes it positive. I'm going to write this out so we don't screw up. 12 over 13 times 13 over 5. Those cancel, leaving me with 13 over 5 plus 12 over 5. We're just going to make it equals, hold up, 25 over 5. Can we still see it? Yes, we can. All right, cool. Equals 5. All right, that answer right there, quite satisfying, and it fits on my camera there. I can see on my watch, fancy. Yes. All right, 5 is the final answer. There we go, man. 3 problems. We barely fit all that. That's a lot of math right there. I like a lot of math. Okay, it's fun stuff there. But be careful with a couple things. Number 1, is it positive or is it negative? Right, you take your domain restrictions, cut them in half. That tells you where your theta over 2 is going to be, and then you can make your decision there as to whether it's positive or negative. I'll do another one where they end up in different quadrants than rather the first quadrant, so you can see that. So probably the next video in this playlist if you're watching it in the playlist. Otherwise, head to my channel, subscribe, like all the videos, and tell your friends. See you later.